Hello students, welcome to my channel. In this video I will discuss few important formulas, ideas from the modern physics chapter. After discussing the important ideas just like a synopsis, just like a quick revision, then in the further videos I will discuss problems from this topic. Okay, let us start. The first I want to discuss here hydrogen atom. So Bohr's theory of hydrogen atom. Bohr's theory of hydrogen atom. So what are the important formulas that required to solve the problems related to Bohr's theory of hydrogen atom? Okay. The first point I want to discuss here, energies that are involved. Energy generally we write h nu, hc upon lambda. Then how you will calculate this value? Suppose energy I write in electron volts. Energy in electron volts. Then hc value will be approximately it is 1242 divided by lambda in nanometers. This is very important relation. We frequently use this relation. So in the numerator it is 1242. So that means hc value indirectly 1242 electron volts nanometer. Okay, this is the first formula I required. The second thing what is required for me here, angular momentum of the electron with respect to nucleus. So here I assume nucleus which is at rest here, whose charge will be ZE, whose mass is infinite mass of the nucleus is infinity, and the electron is revolving lighter particle in a circular orbits with a certain velocity. Okay. So for this type of systems, what will be the radius formula and what will be the velocity formula, what is the total energy and all those things. One of the important postulates of Bohr's theory is angular momentum is conserved and it has the integral multiples of nh by 2 pi values. So angular momentum of the electron with respect to nucleus is given by r cross p, that is cross product sin 90 will be there, r into p, that is r m into v is equal to nh divided by 2 pi. N is the principal quantum number, it has the values 1, 2, 3 and so on. Okay, here Rn will be the radius of nth orbit, Vn is the velocity of nth orbit. So radius of nth orbit will be given by R1 multiplied n square upon z. Then here I will write R1 value. R1 value is epsilon naught h square divided by pi mass of electron into E square. Its value comes out to be 0.529 angstroms. Velocity of the electron in the nth orbit will be V1 multiplied by Z by N. So here V1 comes out to be E square divided by 2 epsilon naught h. Its value comes out to be speed of light divided by 137. After calculation it comes out to be 2.19 into 10 power 6 meter per second. Okay. Then after knowing this, let us go for the total energy. Total energy of an electron will be E1 multiplied by Z square by N square. So where E1 is the energy in the first orbit, it is minus 13.6 electron volts. So this is the Z equal to 1 and N equal to 1 hydrogen atom energy, ground state energy of hydrogen atom. Okay, so actually speaking this E1 will be is of minus m e power 4 divided by 8 epsilon naught square h square. This is the entire value. It comes out to be finally 13.6 electron volts. Okay. So if you want the kinetic energy is simply half mv square. After simplification, what I'll get here, the kinetic energy magnitude is same. Kinetic energy only positive value. It is same as that of the magnitude of total energy. If I talk about the potential energy in the nth orbit will be, it is after calculation. Of course, the potential energy will be 1 by 4 pi epsilon naught product of the charges of nucleus and electron divided by separation between them. If I substitute there, it will comes out to be twice the total energy. Twice the total energy. And of course, potential energy is negative. So remember here, we have taken the reference will be at infinity 0. Reference potential energy at infinity will be 0. Generally, if you want the potential energy, U will be is equal to, generally we write integration of f dr plus some reference potential. Plus some reference potential we need to write. So as we have taken at infinity potential energy will be 0, then it simply U is equal to minus of integration f dr. So these expressions are very, very essential. You need to remember for the quick solving of the problems. Now let us talk about the emission spectrum. So when an electron jumps out from in the emission spectrum, electron comes out from excited state to the ground states. Excited state, this is the initial state, and finally comes out to the lower states, maybe ground state, maybe other states. So higher level to lower level, finally it comes out here. It not necessarily ground state, remember. It emits a photon that will have the wavelength. Wavelength of emitted photon, according to Bohr's theory, it is given by z square multiplied by r into 1 by n final square minus 1 by n initial square. This expression is important, you need to remember, where z, of course z is atomic number, r will be the Rydberg constant, so its value comes out to be m e power 4 8 epsilon naught square h cube into c. So after substituting all the values, it comes out to be 10 power 7 meter inverse. But generally I require the 1 by r value. So 1 by r values comes out to be approximately 912 angstroms. So you can have this idea. Okay. So when an electron jumps from excited states to the lower states, it will emit a photon. So this is generally we call as emission spectrum of hydrogen atom. So in this emission spectrum, there are few important series will be there. Lyman series, Balmer series. So Lyman is the one electron finally comes to the ground state. Initially it can be anywhere. Initially it can be on 2, 3, 4 and so on. So afterwards Balmer series will be there. Finally the electron comes out to be the 2, and initially the electron can be anywhere 3, 4 and so on. So similarly Fachn, bracket, Fund series will be there. So most of the cases for us Lyman series, Balmer series are important. So Fachn series also if you want to write, finally the electron comes out to be 3 and initially it can be 4, 5, 6 and so on. So the Lyman series lies in the ultraviolet region. Balmer series is the very, very important one. It lies in the visible region. So Fachn series obviously lies in the infrared region of electromagnetic spectrum. Okay. So you remember all these points. Okay. Done. So all these relations, radius relation, velocity relation, energy relation and all those things are important. How they will frame the questions in the competitive examination we will discuss in the further videos. Suppose if they are asking something new, say for example, what will be the time period of an electron? So that time you can usually calculate. Time period will be simply, I can write to complete one rotation 2 pi r, and it is with a velocity Vn. So I know the expression for Rn, I know the expression for Vn. If I substitute here, then Tn will be, in the first orbit say it will be T1, then automatically come out to be n cube divided by z square, like this. So basic things are radius and velocity. If we have the basic things, then rest of the things we can calculate. Okay, fine. So another important thing is, sometimes nucleus may not have the infinite mass. So nucleus is also in motion. So nucleus of finite mass. Nucleus of finite mass. When the nucleus has finite mass, so we assumed initially nucleus is at rest. But sometimes nucleus is also in motion. So when the masses are comparable, then that time what will happen? The system will rotate about the center of mass. The system will rotate about the center of mass. So let's say the separation between them is again some r. So in this case, what will be changed here? So everything will be same. The angular momentum part will change. The angular momentum will be again, of course, nh by 2 pi. So this time I need to write, it will be I omega. I omega. I will be the moment of inertia. That I'll write here mu r square into omega. Okay. So mu will be generally I call as a reduced mass. Reduced mass of the system. So reduced mass will be defined something like this. So I hope students knows this. So if I consider the finite mass of the nucleus, and which also contributes for the total energy, and everything will change now. The formula for radius in the nth orbit will become r1 multiplied by n square by z will come. Apart from this, there is another factor, mass of electron divided by reduced mass. Similarly, energy in the nth orbit is comes out to be, so E1 into z square by n square into mu by m. Okay, so like this formulas you need to remember. So this type of cases where the effect of nucleus also be considered, so rarely comes this type of questions, but you need to remember what happens here. You just replace mass with the reduced mass. So if I replace mass with the reduced mass, then things will change according to this formula. Okay. Let us discuss other important points. So this is enough related to the Bohr's theory of hydrogen atom. Now let us move to the another important topics, that is de Broglie concept, dual nature of matter. So dual nature of matter. Dual nature. So the particle will be associated with a wave, generally that is known as a matter wave, that is given by the wavelength and linear momentum related with them with each other as lambda equal to h by p. H is the Planck constant, lambda is the wavelength, and p is the linear momentum of the particle. So if a particle is moving with a velocity some v, then momentum will become like this. So this momentum has a many versions. So momentum can be mass multiplied by velocity. It can be related with the kinetic energy. So momentum p is equal to, so kinetic energy and momentum are related as kinetic energy is p square by 2m. So because of this, this can be written as p will be square root of 2m into kinetic energy. So when an electron is or charged particle is accelerated through some potential difference, kinetic energy will become charge multiplied by the potential difference. So that is h divided by square root of 2mq into potential difference. So similarly, there are many ways like thermal energy. If we are providing thermal energy, the kinetic energy due to its translational motion will become 3 by 2 kT. K is the Boltzmann constant here. So in place of kinetic energy, I can substitute as 3 by 2 kT. So if I substitute the 3 by 2 kT there, so 3 kinetic energy by 2 cancel, 3 m Boltzmann constant multiplied by T. T will be the temperature here, be careful. T will be the temperature. So most of the time we required what is the de Broglie wavelength of electron when it is accelerated through some potential difference. So this is the formula here. That means lambda will be is equal to h divided by square root of 2 into mass of electron, charge of electron into potential difference. After substituting everything, I'll get lambda in angstroms will be is equal to square root of 150 divided by potential difference. Whatever may be the potential difference, then accordingly you write that. Similarly for proton. For proton, the value lambda is given by 0.287 divided by root V. So in angstroms, of course. So root V in the sense it is the potential difference. That is potential difference. Okay. So most of the cases we maybe framed a question something like an electron is accelerated, then find the associated de Broglie wavelength. For electron and proton you remember. For any other things you have this relation, from there we can get anything. Okay. So related to dual nature, this much enough. Let us discuss about the Einstein equation of photoelectric effect. So what is photoelectric effect? The photoelectric effect is simply says photoelectric effect. So there is a metal. So when the light comes and falls on the metal, then there is an emission of electrons. So simply based on energy conservation, Einstein given a relation. That Einstein relation, incident energy will be is equal to work function, that is the minimum energy required to knock out the electron from the metal, multiplied by maximum kinetic energy of the electrons which are emitted. So the energy can be written as h nu, work function, that is the threshold energy also we call it is. So maximum kinetic energy, even you can write it as a in terms of maximum speed. So sometimes even we may write energy h nu in terms of a wavelength hc by lambda into work function. Sometimes maximum kinetic energy we write in terms of the stopping potential. So here Vs is the stopping potential, that is amount of potential difference between the emitter and collector required to stop the moving electrons. Okay. So this equation will help a lot to solve the problems related to the photoelectric effect. Okay. So apart from that, few other points to remember here. What is the meaning of intensity? So intensity of light in the sense energy per unit time per unit area. Energy per unit time means maybe n number of photons are there. Each energy will be h nu divided by T into A. So from here, if I write for the number of photons per unit time, I can write here I A divided by h nu. Okay. So in this way I can relate with the number of photons. So number of photons per unit time is directly proportional to intensity. More intensity means more will be the number of photons incident per unit time. Okay. So energy incident per unit time is also even called as the power of the source. Okay. Fine. Yeah. Other important thing I want to discuss here, X-rays. X-rays, you can say reverse of photoelectric effect. What happens when a fast moving electrons are coming and falling on a metal plate? So when these electrons are coming and falling on a metal plate, so most of the part of kinetic energy will lost in the form of heat, but some part will appear some new rays generally called as the X-rays. So that means the kinetic energy of the fast moving electrons will be is equal to X-rays energy plus much amount of heat is evolved. In the ideal case, no heat will be revolved. Then kinetic energy of the fast moving electrons will be converting into energy of the X-rays. So that means that this relation kinetic energy, let's say simply E, h nu I can write hc by lambda. So again the same relation. So that means if I want the wavelength of X-rays in nanometers, you write hc value, that is 12242. Write the kinetic energy of the electrons in electron volts. So that means electrons are accelerated through high potential difference and they will go and collide with the metal surface. During the collision they lost the energy and most of the energy will appear in the heat. Only few amount of energy will appear in the X-ray spectrum. Okay, so X-rays will have generally 10 angstroms to 100 angstroms wavelength, very less wavelength, so high frequency and high energy. So related to X-rays, another important law will be the Moseley's law. Moseley's law. So according to the Moseley's law, when an electron, a fast moving electron, goes inside and interacts with the atomic electron, so they may knock out the electrons from the K shell or L shell or even from the M shell. If the electron is knocked out from here, a vacancy is created here, then electrons from the higher orbits will come and occupy that position. So K shell, L shell, M, N. K, L, M, N. If there is a vacancy here, the electrons can occupy from here. This is called as the K series of the photon. If the vacancy is here, electrons will come and occupy here. This is the L series. So according to Moseley, there is a relationship between the frequency of the photon emitted and the atomic number of the metal that we are using here. So here we are using some metal on which the light comes and falls, this metal. So this metal target we call metal target. So here Z is the atomic number of that metal targets. So even you can write it as C by lambda, wavelength of that emitted photon. Generally we call it the characteristic X-rays. So A and B are constants for a given series. So for example, if I talk about the vacancy in the K, that is K series. If the vacancy is in L, L series. So the K series, the values for K series will be, so A is equal to square root of 3 RC upon 4 and B will be is equal to 1. And for L series, if I talk about L series, A is equal to square root of 5 RC by 36 and B will be is of 7.4. You no need to remember, generally they will give in the problems. For any series you can remember A value is square root of RC into, so 1 by n final square, 1 by n initial square. If they are giving in the problem, then you take directly that value. If they are not giving, then we can approach this value also. So this is based on the hydrogen atom concept. Be careful. So A and B are the fixed values for a given transition. It is independent of the rest of the things. Okay. So this much is enough related to all atoms, hydrogen atom, dual nature, photoelectric effect and all those things. So a little bit related to the nuclear physics is required for us. A little bit of nuclear physics is also required. Not much. In the nuclear physics, they'll ask about for the mass defect. So the mass defect and the binding energy. So the binding energy comes out to be mass defect into C square. Okay. So after that, they'll give some reaction and they will ask you calculate the mass defect, binding energy and all those things. For example, let's say if I consider the alpha decay. There is a unstable nuclei after emitting alpha particle, that means helium nucleus. There is a Y nuclei, that is Z minus 2, A minus 4, and then some amount of energy will be released, Q value. We generally say the Q value. In what form this Q value will appear? That is kinetic energy of alpha particle and kinetic energy of Y. Okay. So, how you will calculate the binding energy? So, Q value, how you will calculate here? Q value we can calculate here. So, mass of X minus mass of alpha particle plus mass of Y. So, this is the mass defect multiplied by C square. Okay. So, we will get automatically the answer. So, this is true for any reaction even, in fact. This is simply for alpha decay. Even if you go for the beta decay. So, in the beta decay, there are two decays will be there. One is electron decay, another one is positron decay. In electron decay, a neutron will convert into a proton and electron inside the nucleus. In case of this, a proton will become a positron and of course one neutron. So this type of reactions are also important. For example, there is an X nucleus will be converting into an electron. So then there is a Y, that is Z plus 1 into A, and there is another particle anti-neutrino. So anti-neutrino is important here to conserve the spin angular momentum of the reaction and of course Q value. The Q value will appear in the form of kinetic energy of the electron, kinetic energy of the Y and kinetic energy of the anti-neutrino. Similarly, if I consider the another reaction, so anti-particle of electron is released, then there is a Y, Z minus 1 into A plus some Q value. The Q value again will appear in the form of anti-electron plus Y plus neutrino. So neutrino and anti-neutrino, the role is very simple. They will carry the spin angular momentum. Just they conserve the spin of the system itself. Okay. Then apart from this, if I go for the radioactivity, so the radioactivity, statistical law of radioactivity is required. So minus dN by dt, the rate of decay, generally we call as a activity, is lambda multiplied by n, where lambda is simply the disintegration constant. This is simply known as an activity. So number of active nuclei at any instant is given by like this formula. This is the equation for number of active nuclei. What about activity? Activity is lambda multiplied by n, that is A naught initial activity e power minus lambda t. Okay. So important things will be the half-life. The half-life is linked with the disintegration constant lambda like this, and average life is linked with the disintegration constant will be something like this. Okay. So simple formulas only required. They'll ask based on this. Another things to revise here is the semiconductors. So in semiconductors, you must know the band theory of solids. So band theory, which has introduced valency band, conduction band, energy gap and all those things. Along with that, you should know what is the meaning of p-type material and n-type material. So after that, you should know what is the meaning of p-n junction diode, forward bias characteristics, reverse bias characteristics, and importantly there are special diodes will be there, GNR diode, photodiode, LED and all those things. Just simply go through the NCERT book, that is enough. Okay, then problems will be asked based on the Zener diode and photodiode, and very importantly logic gates and their truth tables. So simply for us, AND gate is there, and OR gate will be there, and a NOT gate will be there, and of course NAND and NOR, they are the universal gates. Okay, so these are the things which are required for us. These are mostly theoretical questions. If they want like some problematic, they frame from Zener diode or PN junction diode, current equation is given, and they are asking what is the dynamic resistance and all those things. Apart from that, whatever you have learned in the current electricity chapter, for example, we may require the drift velocity, we may require the current density and drift velocity are related as NEVD. Okay, so generally here I require the total in the sense electron drift is also there and hole is also there, both are there, like that. Accordingly you write the concentrations and you can calculate mobility, whatever the relations we have used in the current electricity chapter, the same relations are also we can utilize in the semiconductor chapter. Okay, fine. So this much enough in the modern physics chapter. These synopses are very essential. If you remember these formulas, we can solve the problems in the further videos. You can understand easily. Okay, thank you very much. Please subscribe my channel. Don't forget like and share. Thank you very much.